computing and data center automation. I've been both on the IT side of the house and on the tools for IT side of the house as well. So in fact, I kind of like to switch it up every few years, and just so that I can understand what the latest set of problems is. And so the topic we're covering today is zero-touch management environments. We used to call them lights-out data centers, but zero-touch sounds cooler. And so now we're going to call them zero-touch management environments. As always, on the enterprise side, these things have been around for a long time, but this technology and this approach to doing things is somewhat new in the telecom space. And there's a reason. Well, there we go. And the reason it's even part of the conversation is because of 5G and the IoT use cases. So the 5G and the IoT is yet to emerge in its fullest scale, but there's fear that we're going to have a lot of connected things, connected devices on the network. Some people will say 50 billion, maybe more. If you think about what it means in terms of management and in terms of being able to spin up the services and the network slices on the fly, if you think about all the mobility use cases involved in 5G and IoT, the level of management complexity is going to be pretty unprecedented. It's not an easy problem to solve. As telecom space, as NFV in particular space adopts cloud computing for network as a service deployments, the deployment scale goes across multiple geographies, across multiple locations. So again, the level of complexity goes up as that happens. And for the first time, there's a lot of emphasis on intra or inter-opco collaboration in order to provision different network services. And so again, these kinds of environments didn't need to exist before that much. Now, the worst part of it is that there's a lot of demand in terms of a lot of demands for high degree of fulfillment velocity. We're dealing with situations where somebody is driving a car with a GPS and streaming maybe video and all sorts of other things, and as they go from I guess maybe I need to really hold it close. And as we go from one region to another, things need to flip over, and you're roaming, and all of that needs to be flawless and happen in real time. Nobody wants to see their GPS go out to lunch and then come back 10 minutes later. Lots of different use cases around that require very low response time and high degree of background management operation or high velocity of management operations. At the end of the day, all of these things and all of these concerns kind of boil down to cost, right? What is it going to take to support? How do operators make this environment efficient? And how do they eliminate all this different complexity? There we go. And if we look at how we manage networks today, it's a very human-intensive task. There's lots of centralized network operation centers, lots of people are involved. It's very much a reactive environment. We still haven't learned how to do things proactively. It's very much a bespoke, very customized environment. Most of the solutions in the telecom space is still based on vertical stovepipes from individual vendors. Everybody's used to buying solutions from a single vendor, top to bottom. Everything is tightly coupled, and when you do integrations, there are lots of point-to-point integrations. And so it's a bit of a pain, and really doesn't lend itself to the sort of latency requirements and delivery velocity requirements that 5G will demand. And so virtualizing all these network functions is not going to be enough because, again, the complexity is still there. And so we want to make sure that as much as possible, how we manage networks, how we manage services is simplified and automated to a point where we can eliminate the human error out of the equation. Now, if you think about all the complexity, the more complex the environments are, the more likely people will make mistakes, right? And so the idea is to really, as much as possible, eliminate the human presence out of the loop day to day. Let's see if we can get this. Here we go. And so really the impact of zero-touch management is that we go from we kind of shift, I guess, from a model where we have humans taking care of machines to a mode where machines take care of machines. Some people call this the autonomous data center approach. Like I said, we have lots of names, but in the old days we used to call them just lights out environments. And so what does it all mean? At first it means that a lot of day-to-day operations are not done by people anymore, right? Because again, the degree of complexity and the scale forces automation to take over, so that the fulfillment and the operation can happen fast enough and the latency of the execution is low enough. And so over time we get to a world, and this doesn't happen overnight, of course. Nobody's going to trust, in automation, in one day. Everybody's worried about the Skynet scenario. But over time, the idea is that we want to get to a point where the management functions don't require human presence day to day, right? And there may be some presence, but most of that is going to be focused on oversight of what's going on and kind of holding your hand above the red button that says stop, and not so much doing the actions themselves. And then as you keep running these environments, the hope is that you will gain enough trust, you'll have enough comfort that you don't even need to watch the system. It'll just kind of work on its own, okay? So that's a pretty, for those of you who worked in data centers, I don't know, maybe just for the sake of asking a question, how many people have worked in data centers? Actually on, the data center floors with all the, yeah. And so all the things that people do that we take for granted inside a data center, all the planning tasks, all the things that you use your intuition for, to kind of watch around and predict, all of that all of a sudden goes away, and the intent is to replace all that with machinery. And so just think about that, right? We take a lot of things for granted, what a human mind is. But again, it gets to a point where you can't just keep up. And so something has to take over. So next, we're going to kind of go through some of the challenges that we face with that, and also get into some basic architectural kind of design principles for what these management platforms might look like, okay? So first, the trust part, right? We say trust but verify. A wise man once said that. And really what it means is that you're not gonna go and say, okay, I can go home now and have a cup of coffee while these machine functions run the world. You're going to slowly let them in. And so you kind of end up with these two knobs. One controls the level of autonomy, and the other one controls the degree of trust or oversight, right? You may have a system running at the highest level of autonomy, but you still may want to keep an eye and make sure it's doing the right thing, right? Because you're not trusting it yet. But over time, you will, hopefully, and so then you can kind of dial down the oversight a little bit until you get to a point where the thing is running itself. The data center is basically doing its thing. obviously, as you dial down the level of oversight, your throughput, your performance of the whole autonomous environment goes up, right? Because you're not really interrupting it to see what's going on and what decisions are being made. So this is key, though, right? Because again, it's going to take time. Every time I do this talk, some people always ask, "Oh, well, what are you trying to do? Put us out of a job?" And then, no, the job changes, right? The job kind of changes more into being able to be in the background and kind of look at the big picture as opposed to dealing with the day-to-day functions. But this is how you accomplish that. And so in terms of basic characteristics and qualities, we kind of have a couple of things happening here. If you get the people out of the equation, then things have to become what I call selfish. Self-configuring, self-optimizing, self-healing, self-protecting, and self-service. So think about a simple task of bringing spares in and swapping out bad parts that everyone in the data center has done. And what does it typically take when people are there? Well, somebody has to go and get the boxes and unpack them and cable up the new machines, take the old ones out, put the new ones in, configure them, do what needs to be done to get them to work right. Oop. And we're on the brink here because the machines are running the world while I'm talking. So, but in the world of zero touch management, you've got situation where you kind of have to do all that automatically, right? So you have to do self-configuration. Now that also implies that how we build hardware, how we build systems to support these environments will have to change, right? You're going to have to build a lot of smarts into the individual hardware components to be able to assess who the neighbors are and be able to talk to those neighbors in an intelligent way and carry on a two-way conversation while you configure, the devices configure themselves into existence, or even augment the existing configuration for based on something that just appeared next to them, right? This is not a new concept, by the way. If you look at how Apple does configuration of laptops and printers and all sorts of devices, they've been using something called Bonjour, right, or ZeroConf for a long time. So the concept has been around, but now you have to bring it down to the basic hardware component level and be able to swap it in and out. Again, there's a big question of who's actually going to deliver the components and who's going to receive them if there are no people. So you might imagine all sorts of drones and other things kind of involved in this eventually, a long time from now. But again, it's an incremental process, and so about 10 years ago, I was involved in building one of these lights out facilities for another company in the valley. The vendors would actually deliver the spares by helicopters because the roads were really bad, because the data center was parked right next to a big, huge dam, for cheap power. But they would drop off the spares, and every 2 weeks, 2 technicians would drive in or fly in, and they would replace everything, and then they would leave, and the data center would run on its own until the next repair has to be done. And everything was done remotely, including the basic management, basic monitoring, everything else. And so the idea is that, when you do things remotely, when you do that oversight remotely, you still have to have all the machinery on site working perfectly in order to take care of the basic automation tasks, right? And so you have to start thinking in terms of processes and procedures and making things very predictable, very deterministic, very modular. And so all that starts coming into play. And so you end up with a certain set of operational qualities where, if you don't have these, you don't really have a zero-touch management system. And the first one is trust and being tamper-proof. You can have all the greatest, machine learning features and AI features and automation in the world, but if you can't trust that environment hasn't been tampered with, you've got problems, right? Now you can't really trust your environment. Now you will never be able to let go. So trust and tamper-proof are the first two that are pretty important. And then everything has to be predictable and deterministic, as I said. There's this principle of least astonishment that we use, to kind of, you never want to be surprised. You want, your automation to do the same consistent set of things all the time under all the same conditions. You don't want to have an anomaly. And then if by chance things do go astray, you want to be able to stop things. You actually need to make sure that that big stop button that you have, behind the glass or whatever, actually works and actually stops, things from going further in a bad way. And then finally, everything has to be available all the time on demand, right? So it's really, what we're looking for here is certainly a cloud-like environment, or a cloud environment, if you will. So the other thing that happens here is the way we deliver software into this environment has to change. So most of the time when you're doing operations, you're going to end up with software being delivered in terms of big products. All companies have products today that have a lot of different moving parts and components. When you build on-demand systems, you can't shut the system down. You're basically making it available 24/7, and especially when you're building network as a service environments that is zero touch. And so the more complex your software refresh looks, and the more you have to do, the more risk you run of breaking things. And so you kind of want to make things smaller and more modular and more functional. And so instead of delivering big, huge products, the idea is to start shifting over to the delivery of software components. Now, in today's world, we think of microservices or little small services as those components, right? And the idea is to be able to continue to evolve those, continue to improve their functionality, and be able to publish them somewhere, like a marketplace. And then allow the vendors or the providers who have deployments that are zero touch to be able to download the changes and deploy them as they see fit. And so what we're doing is creating that separation of concerns when it comes to CI/CD. Okay? But again, the idea is to make the delivery is more service-centric, more function-centric, as opposed to product-centric. Now, what that also allows you to do is have the benefits that marketplaces usually bring about. You could, download something, test it, see if it works the way you want it to, and if it doesn't, then you just replace it with another implementation. And so the competitive landscape is still there. It's just on a smaller scale. And then, of course, the architecture of the whole end-to-end system has to be very consistent, right? It's got to be cookie cutter, and it really doesn't matter if we're talking about the edge or the core or something in between. You kind of want to have this cookie cutter approach as much as you can throughout the implementation of your system. Again, because you want things to be predictable and modular and deterministic. Right? So the smaller the pieces are, the more well-defined the functional boundaries are going to be, the easier it's going to be to replace broken things or find what the problem is and isolate it. And so if we look at what it takes to build an environment like that, the first kind of principle is that the platform has to be model-driven. Right? So if you look at the left side of the screen, this is a typical, set of things that you manage inside a data center, right? From facilities all the way to business processes. This is what IT does, no matter, whether it's enterprise IT or telco IT, everybody has to do these things. And so these are administrative domains. Each one has a model. And that model essentially describes and defines things that you manage within that domain and how things interact in terms of interfaces and what happens. And so what you want to be able to do is apply that to a set of zero-touch management domains, which is a fancy way of saying, well, what do I have to care about managing if I'm building a zero-touch system? Well, I have to manage myself, because nobody else is going to do that day to day. Then I have to manage the resources that I rely on. I have to make sure they're functioning properly and that I have enough capacity to run and execute. Then I have to take care of all the services, all the network services that I'm running as a payload. And then I have to worry about the resources. So these 4 things I have to be able to do. And so ideally, the way you model your payload is the way you would model your own componentry from a zero-touch perspective. The more symmetry you have, the more commonality you have, the more consistency, the more patterns you can establish, the better off you're going to be, because again, small, modular, model-driven things are easy to manage. They're more predictable. Second thing is life cycle, right? You can't just say, oh, I'm going to pick and choose what I do. You kind of have to look at the entire life cycle of different things that you have to be able to operate and manage. And so this is a generic enough life cycle that includes the green stuff. You can kind of, development maybe is more software centric, but for a hardware vendor, it's developing a new system or assembling a new solution, right? There's always going to be something that your vendors are going to do. So that's the part in green, and the part in blue is what you would do. In an automated way. And so there's that point of delivery, and then now you got to onboard whatever it is that you just got, got to test it, got to put it into production. All of that stuff, again, needs to happen automatically with little or no adult supervision from the operators, right? So self-configuration is one thing, but self-optimization, self-assembly, all, and how do you do it securely? How do you trust that whatever you got delivered has actually not been tampered with, right? How do you know that the network functions that you're going to be running that you just received from a vendor have not been tampered with, right? How do you make sure that when they form a chain of VNFs, right, inside your network service, that it's a trusted chain, and then it's running on top of a trusted computing environment, which depends on a trusted hardware, which depends on a trusted network, right? That's the kinds of problems that we're looking at. By the way, this is all kind of early days, and so the expectation is that over time, a lot of companies who are in the OSS BSS space are going to start building solutions here. And so we want to make sure that things don't go in 20 different directions. So there's actually a standards body focused on zero touch. It's a telecom-centric body. It's under the ETSI umbrella, and it just got formed in January of this year. And it's called the Zero Touch Service Management ISG, Industry Specification Group. And what we're trying to do there is to define the actual details of how these hardware pieces find each other and how they interact, how do they configure themselves, how do they self-protect themselves from failure, how do they interact with other systems, and so on and so forth. So if you want to check it out, you don't have to be a member to look at some of the public work. We started publishing drafts of specifications. It's still early days, but the drafts are available to everybody. We made a choice that we wanted to open it up to the industry. And so we're kind of cooking the sausage, as they say, right in front of everybody. So if things look a little ugly, that's because it's only been 3 months. So lifecycle centricity. Next thing is platform modularity. And so what we really want to be able to get to is this environment where you can plug things in, take them out, replace them as you go. And so you're kind of looking for what we used to call in the old days a field replaceable unit sort of behavior, right? Except that now you may have software components that need to exhibit that behavior, right? And a FRU or a field replaceable unit, you just kind of plug it into a backplane typically, right? And it's a well-defined interface that you have, and And so every FRU has exactly the same interface in terms of how it's managed and how it exposes its functions and so on and so forth. And there's been a lot of work done in the industry, actually, in the standard space and the TMF space to create interfaces like that. And the reason why is because they also like modularity, and they also like to be able to build services in a very normative and very well-defined way. But the idea is that you're not just building new stuff, you also have to be able to integrate the old stuff as well. And so you can take a legacy product and create adaptations of that product in such a way that you have a one-to-one mapping, or you can do some refactoring where you take multiple legacy products and combine them together in terms of behavior to create a new interface. Or you can split a product logically in parts and create two different functional interfaces. So again, the idea is that these adapters, these interfaces that you're creating, they kind of define the functional boundaries of things, right? And again, well-defined modular pieces. And then we get to the fun part, right? How do you actually do the thinking, the learning, the adjustments, and the self-tuning and everything? And so in a traditional space, we used to have the typical closed loop automation systems, right? Typically have one for the infrastructure, you have another one for services that you run on top of it. Every Mano stack out there that you have for the telecom space, or every cloud stack has those two loops. And there may be many other loops inside that big one, so it's a decomposition. But in general, what you're doing is collecting data, you're getting telemetry, you're gaining insight based on what you've collected, you're analyzing it. Based on that insight, you're creating changes or creating plans on how to modify the system, and then you actually execute the workflows that constitute the actions that you want to perform. And so these workflows today are by and large defined by people. The idea is in the future that you can dynamically compose these workflows, again, depending on what the situation is and what you need to do. And again, for that to happen, you have to have well-understood, predictable behavior of different parts. But that's not enough in the zero-touch world, because now you kind of need to go one step higher. And so we end up with this other layer on top, which is kind of new. And that's where you manage knowledge, right? So, that's sort of like the high-order brain functions. You can automate the low-level workflows, but what you're really after is the policy-driven approach to doing things. So you got to define the policies. You got to define the basic rules for how things operate. And so the way this would work is that you would have an initial set of policies that would be seeded by administrators, and then based on those initial set of rules, by using ontologies and semantic web relationships, you can start building you can infer other relationships, and you can start building other policies on the fly. This is going to take time. This is what real machine learning really is going to get us to at some point. But today, whatever we do in that space is still going to be fairly human intensive. But again, it's a journey. It's not something we're going to accomplish in 1 year. But the point is that you need that layer in order to provide that kind of global oversight across your services, your infrastructure, and different locations, and different places where you have your equipment deployed, and so on and so forth. And that's not enough either, right? Because what you really want to do is provide more feedback, right? Don't forget the developers. And so you have the development lifecycle, and it's being done based on requirements and prior knowledge of how well things worked in the past. You have that brain, that policy management layer. And then you've got the basic operation and orchestration functions and services and infrastructure. And what you're really looking to do is connect them. So you have these multi-level feedback loops that allow you to not just continue to tune and define and optimize the policies and the workflows, but as you do that, you're feeding the results back to the developers. So they have real-time knowledge of how things are performing. And in some cases, they may be running analytics back in the development environment saying, oh, this thing is about to fail because we've seen these kinds of failures before, and so maybe we need to patch. Maybe we need to improve, how things are done. I'll give you an example of this from, a real world. Airplane engines send telemetry to the factory and to the pilot at the same time when they're in use. The factory uses the data to optimize the design of the next generation or to predict if there are bugs that are about to happen. An aircraft engine is a pretty important piece, right? So, and then the pilot gets a different set of telemetry to fly the plane and to use the engines. But that's the idea, is that we want these software components that are being deployed to actually be self-sufficient enough to keep sending the data back, right? So that, continuous improvement can be made. And so that allows us to kind of become more predictive and avoid the errors, hopefully, before they actually occurred, in the worst possible way. So feedback-driven quality is another very important aspect of zero touch. Okay. So about a year ago, a bunch of companies got together in Europe, and the companies were from all over the world. And we spent a bunch of time kind of saying, okay, if we're going to build this world of autonomous systems and manage things without human intervention, what would the basic architecture kind of look like? What would we have to do? And how would we make things more modular? And there's no rocket science here. We actually looked at what companies like Google and Facebook were doing. The enterprise world is always ahead a little bit. We have a lot of companies there that operate at web scale, which is even, greater than that individual operators operate at. A lot of the same requirements are there. And so this was a reference architecture that we defined. There's a white paper that we wrote. And there's a bunch of presentations that were created in order to explain what this is. And if you're interested in finding out more about this, and again, this was highly experimental work. A lot of this was published at the inception of the industry standards group at ETSI, right? When we decided that for the best of all the participants, we would classify this as sort of initial explorations, right? Because not everybody who is participating in the ISG is agreeing necessarily with this particular approach. But this particular architecture assumed a cloud-native implementation. It assumed microservices. It assumed a decentralized federated model where your management plane was not in a single spot, but it was really deployed geographically in a geographically distributed way where the workload components were. And so a very different environment. Now, once we kind of published, the details and all that, one of us found a Google paper. So we looked at it, gee, the slides look a lot the same. So that was okay, and we kind of liked the fact that somebody else thought like us, until we looked at the year of the paper, and that was like 4 years before we got together. So always ahead. But if you're interested in the details, go to the ETSI website. And you can look up some of these initial findings and initial reports that we've done. There's a lot of industry collaboration that happens in this space. We're working with other standards bodies, other open source communities to kind of make sure that we can jumpstart this, right? Because 5G is not that far off in terms of production. And doing this after the fact is going to be a lot more complicated than building something ahead of time that kind of at least can scale or right size itself with the scale of the 5G deployments. So I think this is my last slide. Yes. I have to display the obligatory notices and disclaimers and all that, and so this is the end. May sound a little bit like science fiction, but again, you know, like I said, this is stuff that's been done and it's been around for a long time. So now we just have to refactor it for the networking space and make sure that it addresses all the regulatory compliance, all the requirements that the telecom industry has that the enterprise doesn't. Questions?
Yeah, I have a question.
Ah.
So you mentioned about Google, right? Are we working with GCP, the Google Cloud Platform?
So, you know, you could, the way the architecture was developed, we didn't discriminate. The idea was to use a container-based environment as a way of deploying the management plane. And the idea was to create a microservice marketplace that different vendors would contribute to. Kubernetes obviously is the predominant environment. And again, you know, there are lots of ways of deploying Kubernetes. Google Compute Engine uses Kubernetes, right? And so the advantage here is that you don't have to deploy this on your premises. You can actually deploy this in the public cloud if you wanted to. And you can use the public cloud resources to actually build a completely virtualized deployment of what's being managed. That's an extreme thing, right? But we're not working with Google yet. There's hope that Google and Facebook will join the industry group. But they have a tendency to join more generic kind of groups that have more of an enterprise and telco focus. And this is, for now, is heavily weighed on the telco side.
Oh, okay. Because Lakshmi Sharma, who leads the Google Cloud, was here. Maybe we can talk offline and
Okay.
Connect the dots over there.
Sure. Hi.
Good presentation. Thank you. Prakash from Delhi. Question to you is, are you, zero touch management involves networking also? So
Yes.
are you, aligned with HCZSM, which is initiated?
ETSI-ZSM is what I've been talking about as the initiative, right? ETSI-ZSM ISG is what we've started.
So this is part of that.
Yes. So Intel is a founding member of that ISG, and I represent the company there.
Thank you. Glad to, yeah.
Good presentation, good visionary aspects to it. I'm KRS Murthy. Is there any hack resilience incorporated expressly, not implied, right? Expressly, what are the hack options that anyone can use? How do you simulate it? And then that's the hack side of it. The second aspect of it is failure mode effects, right? And it's their criticality. How does it become failure resilient, right? Etc. Any clear documentation rather than, yeah, it's understood, right?
Well, it's not understood, right? And so there are lots of options that are being explored, right? One option is to embrace failure. And that's sort of,
the resilience part.
Right. And so not to try and build a fault tolerant system, but to really build a system around.
I see.
Yeah.
But what happens is, even if it's resilient, the hackers will come with their own.
Right, and so that's actually a number one comment, right? Whenever we talk about this, and I did a similar presentation yesterday at the NFV World Congress or whatever it is in San Jose, and first question was exactly the same. How do we deal with security? Self-protection is a big problem for something like this, right? Because again, you have to believe that this is trustworthy, right? And so the idea, and then we had a kind of an impromptu meeting after the talk. A lot of different companies were just standing around a coffee pot talking, right? And there were lots of ideas being thrown out in terms of how do you guarantee tamper-proofness, right? right? Obviously, we have, the hardware level guarantees as part of the TPM environment. We have trusted execution, but there's also a lot of explorations happening in terms of how we use blockchain to actually trace a given component all the way from its birth or its creation, all the way through the supply chain, all the way through the delivery, all the way into production, and actually keeping track of what applications and what tenants this thing has been associated with. So you can actually have a complete history of
assuming that this industry private blockchain
Yes.
the network rather
Yes.
than open public.
Well, so look, I think it really depends, right? My hope is that, you cannot adopt something like NFV and virtualization and cloud computing without changing the process and the people, people's minds on how to use it, right? We kind of have to adopt new ways of doing things. That's tough to do in an environment where there's a lot of regulation and a lot of history and a lot of aversion to change. But I think ultimately for something like this to succeed, we're going to have to look beyond the traditional ways of doing things in the telecom space. Right? This is why when we first got together a year ago as a bunch of companies, there were 14 of us, right? We basically made a decision that if we were going to actually, go and sketch something out, we would not even look at how things are done in the telecom space today. We would only draw upon the experience of the big web scale service providers, just to learn about, being able to operate at that scale and the qualities we needed to have, right? Now we can take those learnings back. Now we can start looking at how do we define the interaction points, what the protocols look like. There's a lot of work being done in the industry on the M2M protocols, which tend to be very different from traditional interfaces, right? And so all of that needs to be taken into account. There's a lot of work to be done, right? Nobody has all the answers yet.
In terms of paradigm, very important that the more and more autonomous we make, in this case, the whole thing there, the knowledge base, the knowledge corpus in doing the old way could disappear. This is happening to USA, where we are dependent on China or India or Russia, whatever it is, for everything. So we will have completely lost the ability, the knowledge, and everything. And is there a clock back arrangement, clock back arrangement being looked at as part of the whole paradigm?
Meaning what?
In case something did not happen, something went out of control, would we be able to come back and have more and more, little more human control?
Well, so those were my two knobs, right? The whole idea is that they're not unidirectional. You can keep dialing up and down what you do, right? So my sense is, and again, based on the experiences I've actually had building these lights out environments, every time you try something new, you introduce a change.
Exactly.
You kind of dial things back down so that you can actually see what's going on and then kind of bring them back to full speed, right? So, nobody's looking to lose their jobs over this, less of all CIOs. So, any other questions?
Good, very good. That's it.
All right, thank you. I think you got all your parts. I did all my parts.
Oh, you did? Okay.
Where's my phone? Let's go. Thank you.
Thank you, Alex.
Thank you.
Thank you. That was great. source ecosystem team. It's part of the Open Daylight team in Ericsson. He evangelizes microservices architecture, SDN, telco, and edge cloud, and has given many sessions and conducted workshops around microservices-based VNF and Kubernetes. He's PTL for Open Daylight Kubernetes Integration Project, and he's spoken frequently at open source summits on Open Daylight, OPNFV, and InterSDN. Prakash has been in the industry for 30 plus years. He has MSE from IIT Mumbai, is an active OpenStack participant, and is a veteran consultant for NFV-SDN in the area of data center and carrier network operations. The companies he has served for are Micronic Devices, IDM, Microdata Consultants, Intelligent Systems. Wow, that's a huge list. AT&T, Mobility, WinVision, 7.com, Coverity.com, AT&T, Labs, FutureY, Huawei, and Dell. He was also part of Valley Startups and other IT Internet data center ventures in late 90s and early 2000. He has experience building NFV POCs using OpenStack ecosystem, and is a regular at OpenStack, OPNFV, 3GPP, NFV, and MEC IEEE forums over the last several years. And he's recently elected part of the OpenStack 2018 board. So huge round of applause for our next presenters.
This is the one, so yeah. Yep, that's right. This should, okay. Check. Hello. Yep. Thanks, Sujata. Thanks all. So it's great to be here again. So just, yeah, I think this works. Oh, okay. Okay. So thanks for the introduction. So I'm Prem, and this is Prakash. Today we are going to do a repeat presentation of what we did in Open Networking Summit early this month. So the whole edge cloud is gaining a lot of traction, and 5G being the main enabler. What is important here is one is the infrastructure part. When we talk about the infrastructure, the whole edge cloud infrastructure, and then the other radio infrastructure that enables the whole edge cloud. But also on the other side, you do need to look at how you design the apps. For example, if you look at the edge cloud as such, you have AR, VR, the drones, then you have industrial IoT, so on and so forth, that are the main prime driving factor for the 5G to gain traction, right? So in this session, what we are trying to do is we are trying to capture, as an application developer, what are the important aspects you need to take care in order to design your apps so that you can exploit the benefits of 5G. So it's a two-part session. The first part I would probably touch upon the microservices patterns, and then the second part, Prakash is going to cover more in terms of the statelet as well as how to maintain state with respect to the application. So that probably, yeah. Yeah, I think probably we need to go into full mode.
View?
View, yeah.
View. Zoom. Maybe.
No, actually, I want to get into full screen mode.
Yeah.
This is weird.
This one you click on. It's not going, I think.
Yeah.
Yeah. Okay.
Yep.
Yeah. You can go back one way.
Yeah. So as you see, there are a couple of things. One is the application requirements. If you look at the application types to begin with, the application can be categorized into two types. One is the offline application, another one is the online application. What is meant by offline application here is, for example, take a cell phone. You do have a VR, AR apps, or you have gaming application. So if you look at it, if your cell phone or if your devices are quite powerful enough, they can host or they can execute the application in the same environment. But let's assume that certain VR, for example, they have to have a lot of rendering as well as compute power. It may not be available in the device. So what happens is you have the front end sitting on the devices, which is a mobile phone, and the back end sits on the cloud, right? So these are the two categories, broad categories, where we can categorize these applications, the mobile applications. And also, if you look at the offline applications, it's mostly the fat client. It basically does a lot of processing within the same device, and you continuously get the data feed from the cloud. For example, take your famous game, Pokemon Go. The Pokemon Go is a AR, VR. It would be mostly an AR game, right? So here, what happens is, if you look at it, if you don't have an internet, it would not work. The reason is it tries to push and pull the data from that of the servers, the Pokemon Go servers that are usually hosted on Google Cloud, and that's how things work, right? Whereas if you look at the online applications where you just have the presentation layer, right? And then all processing is done online, when I say online, in the cloud, and then it requires connectivity, right? One other important thing here is also the key requirements. What are the key requirements? The key requirements being my bandwidth requirement, right? Then the latency, the jitter, and delay related to that of the application, how it can handle, and also the location and presence. For example, when you talk about location presence, most of, for example, Google Map is a location-aware application. Again, Pokemon Go is a location-aware application, right? So in each of it, these are the important requirements that are posted by the applications on the infrastructure, right? Now, whether the infrastructure meets it or not is a secondary question. As we speak, when you don't have the edge cloud concept, all of it goes back to the central cloud and comes back, which means if you are talking about real-time applications or mission-critical applications, you cannot afford to have the jitter associated with the application be supported in the current model. That is where the whole concept of edge cloud comes into picture, right? So in case of edge cloud, I don't want to again get into the edge cloud, but what I want to briefly touch upon is edge cloud is nothing but you have the core cloud as well as the edge cloud. The edge cloud does not have all of it, but it tries to host some compute that would essentially satisfy certain needs. For example, the need might be a response within a few milliseconds, right? So the edge immediately transforms, or it may even basically end your session and then continue to do some offline processing and then get back to the result, right? So that's what these architectures are pretty much driven by HC. HC came out with what we call as it started as mobile edge cloud, but it became a multi-access edge cloud, right? The current version, what we are talking about, is called the multi-access edge cloud. And this particular slide is essentially the current architecture that is defined by HC standards. A couple of things which we need to look at here is the UE app, of course, it sits right there. And then if you look at, there is a user app.
VNF differs. In that case, the VNF has to be aware about what is the requirement from the application and then instantiate or manage the edge based on that particular application. You see what I'm saying? So that's the difference between a typical general purpose VNF and the VNF when we talk about the mobile edge. Right? Let me move on to the next slide. So here, so this is actually one of the things I think would be important for you from an information point of view is ONAP, right? ONAP, there is a new age group that is formed. The intent of the age group is essentially twofold. One is, in order to define what are the requirements ONAP has to get in terms of edge cloud, and also touch upon other areas, for example, use case definition, putting requirements on the application, so on and so forth. So it's a very, very interesting and important group that you can follow. In fact, we have a weekly call every Monday. The group is just beginning or having their initial specs defined. It's a good one to have more knowledge about this. Now, the earlier slide is about the architecture. This specific slide is about the internal working of how things work. If you look at this particular diagram, you do have on the device edge, you have the network edge, then you have the edge cloud, as well as you have the core cloud. Core cloud is our regular cloud, right? In the earlier diagram, I was mentioning about the orchestrator. So if you look at this diagram, ONAP, which is going to be the orchestrator, plays a couple of important roles. And also there is a component called application function that essentially puts in or defines the requirement for that particular application, or it defines what is the application requirements and then ensures whether my mobile edge meets that requirement or not, right? See, most of you are familiar with how a mobility works, how the cell phone works, right? So at any point of time, the cell phone would connect to a particular radio base station, right? When it connects to the radio base station, it also knows in case if that particular connection goes off, what would be my secondary, or where should I switch on, move on, right? So that is just with respect to ensuring that you have the voice as well as the data these days available, right? But here, what we are talking about is an application wherein the application component also has to move from one edge cloud to another edge cloud. You see what I'm saying? Since these edge clouds are pretty much close to the radio base station, there might be a possibility where a mobility of the whole infrastructure gets into play, right? So that's a bit of, I would say, a bit of drastic change in the whole deployment model. So in that case, you do need these functions in order to ensure that the infrastructure meets those requirements, right? So let's take an example. So you have three types of applications, one with green, blue, and another one is a gray. So they are represented by application function 1, application function 2, application function 3. What does these application functions do? The application functions are representative, or they know what this particular UE app requires, right? So in that case, say for example the UE app 1 is corresponding AF1. It basically what it does is, now it needs to deploy the component that are needed for the UE app on this edge cloud. In that case, what it does is, the UE app requests the AF, which is the application function, to create compute for it. It may not be compute, it can also be any other thing. For simplicity's sake, let's say it's compute, right? So the compute here may differ depending upon what I was explaining. It might be AR/VR, it might be a gaming offload, right? Now the UE also provides information. I mean, it might differ. It may provide what is my coordinate, what is my max cost, what is my max latency, so on and so forth. And the moment you have this, here the orchestrator kicks in. What happens is the AF, which is the application function, requests ONAP to create the VNF in the edge, right? Now, ONAP knows, okay, this is my edge cloud. Edge cloud 1, edge cloud 2, edge cloud 3, this is the requirements, this is their characteristic. and it can pick from there. It's more like resource management. It can pick from there which is the closest edge cloud that can satisfy my requirement. Once it's picked, it deploys or it creates the VNF. As I said, here VNF means the app representation or the app proxy or the app itself sitting along with the VNF, where the VNF does specific functions similar to specific to the app, right? So basically what happens is the ONAP picks up which is the edge cloud, and then it figures out what are the characteristics of it, configures it, and then brings in the VNF, right? So if you look at the first one is the request, second one is essentially the ONAP, request to the ONAP, the third one is essentially the ONAP brings up the VNF, and then what happens is the moment everything is done, now the application function informs the SMF to create traffic rules, because traffic rule has to be reconfigured so that the traffic gets routed to this particular edge. And then all of these control functions are done, and then now the UE app gets connected to that of this particular edge cloud, right? So as you see, there is a lot of moving pieces in this whole puzzle, right? The preparation, ensuring that the state management is done, so on and so forth. So the next few slides, what we are going to talk about is, we are going to talk about how can you simplify or how can you make the whole play a simpler one, right? I mean, this is all abstract, right? So in order to give some life, what we thought was, we'll explain you with a sample application, right? So what we did was we took a simple application of a pothole fixer, right? What this particular app does is, assume there is a bobcat which has capability of going to a particular place and then filling up the potholes, right? So here what happens is, there is a dashboard app that sits along with or in the bobcat. The bobcat can be autonomous or it can be human driven.
Then there is a dispatcher app that sits or dispatches the jobs to that equipment. And then there is a pothole fix app, the app that is in core cloud, which has information about the pothole, right? Imagine a city like San Jose, right? There are so many roads, and then the pothole has to work, and the pothole fixer cannot work in tandem during that high traffic hours. So you need to do a lot of logistics as well as analysis before you can deploy this, right? So just to explain it in terms of the function, so the system function would essentially be, okay, since you have seen that there are three parts to it, let me reiterate again. The dashboard app sits on the Bobcat, the dispatcher app sits on the edge cloud, and then the pothole fix app sits on the core cloud, right? So you can see that the dashboard app as well as the dispatcher app are in a way similar application, or they need to work together, right? So if I have to replay this, what happens is the AF request comes from that of the dashboard app, right? Meaning the dashboard app connects with that of the radio base station, and then ONAP knows, or any orchestrator knows, that there has to be something done for this. The Vim, and it basically triggers the VNF. This is the system function, right? So this is typically we saw how things work here, right? Whereas in the application function, what is needed is, it's a bit of real time, wherein it would need to know where the pothole is, which means it gets a pothole image, it goes to the particular location, and then what happens is it cannot just go ahead and then fix the pothole, right? It has to basically look at the current budget, can I have all the resources needed for it, and then fix it. So in that case, the dashboard app, it connects with that of the edge app, and then it continuously gets the data and then proceeds based on this, right? Actually, I want to explain more on about this, but I believe we are stressed out for time. Let me move on with the core part of it. How many of you don't know microservices? Okay. So I see people who don't know microservices to be less, so I'll probably give a half a minute explanation about microservices and then move on to details about it. So typically microservices are nothing but you take an application, identify what are the smaller components that can be independent, and then these smaller components can be deployed as you wish, right? I don't know whether you're familiar with a Google phone that was announced, but I didn't come to market, but it's similar to that of it. What Google did was, they said why the phone should be monolithic. I will give you bricks, right? A brick for your camera, a brick for your other functions. What you can do is you can assemble, you can pick and choose what camera you want and then assemble your own phone. So you can loosely say that a microservice architecture is nothing but dividing a bigger component to smaller functions and then customize it as you want. But I've just kept it simple, but we can probably connect offline to discuss more about it. Now, for a microservice architecture to be realized, there are few building blocks. The building blocks, I call it as microservices patterns, right? So these are those patterns. How many of you are familiar with this? Okay, one. Sujata, is it possible that we get a 10-minute extension to our talk? Okay, thanks. Okay, so I can explain you in detail. So since most of you know microservices, the most important thing is you would need to know first and foremost on how you decompose, right? Given a monolithic application, you should know how to decompose. One is decomposition. The moment you decompose, you need to know how the various components talk with each other, which means the communication style kicks in. In a microservice architecture, another important thing, since the whole application software is divided, or any software is divided into smaller components, you also need to know how do I handle the data part. When I talk about data part, how do I handle a database transaction, right? So you do have lots of questions, right? So there has to be some guiding principle to help you do things in a simple way, and that is where the microservice patterns comes in, right? So this is a reference. This is a very good website if you want to go and learn more about it. Chris Richardson, he is in fact based on Oakland. He in fact was the initial founders of Cloud Foundry. So he has documented a lot about microservices. And this particular thing is one image that captures all of the design patterns, right? So the design patterns are essentially categorized into infrastructure patterns, application infrastructure patterns, and then application patterns. The infrastructure patterns talks about the deployment. It talks about how do I discover the services as well as the communication. The application infrastructure pattern talks about how is the infrastructure work. When I say infrastructure, what is the communication style? How is the security handled? What are the metrics, measures, as well as analysis that can be done, which we call as observability. Then also, when we move to application patterns, you have the decomposition, which I was talking about. Then the query, how do you handle the query, meaning database query. Then how do we maintain the data consistency, so on and so forth. But for our discussion, I have picked only few patterns. The patterns essentially are, for example, in the edge scenario, the recommendation would be ensure that you deploy your apps or the service in container, right? That's the recommendation one, right? The reason I'll talk about later. Then with respect to the communication style, you can probably use messaging because you need to have this coupling a bit looser as against having a tight coupling, right? Then when we talk about data consistency, there is a pattern called Saga pattern. that talks about how to ensure transactions are done, but when the transactions are distributed, how do we ensure that you have those consistency maintained? So that's about Saga patterns. I'll get into details about it in the next slide. Another important thing also I didn't mark it is also there is something called as distributed tracing. A distributed tracing is a framework. The standards for that would be called as the open tracing, which is a CNCF project. The open tracing essentially helps you to trace a single call all the way up to its complete life cycle of the call, and using that particular open tracing, what you can do is you can see what are the bottlenecks that is causing delay in your call to be executed. I strongly feel that you do need to have this infrastructure, because in an edge cloud scenario, you would essentially need to ensure where are the bottlenecks and then address it. So the reason why we are suggesting that the application developer use these patterns is because you see that there has to be mobility happening, right? As I was mentioning, the VNF has to move from one edge cloud to another edge cloud. How do I do? Can I do a VM migration? May not be possible, because typically when you do a live VM migration, there is a bit of requirement that is put on the network. Only if the requirement is met, then only the VM gets migrated. Whereas in case of containers, the whole microservices goes with the fact that the state of that particular application is in a way decoupled from that of the application, so that you can essentially put down or pull down a container somewhere and then bring it up somewhere. For example, Kubernetes, the whole concept of pod, the assumption is it is by default ephemeral in nature. When I say ephemeral, if you say I need a 10 pod, the 10 pod gets created. If one of the pod gets killed, Kubernetes doesn't worry. It creates one other pod and then it keeps running, right? So here, by design, what happens is the data is in a way separated from that of the application. So these are the benefits where if you develop the application based on microservice architecture, you also help in faster mobility and also data consistency. With that, I'll move on to the Saga patterns. This is a very, very important pattern. It basically replaces a two-phase commit. What it does is, let's assume that application, there are 3 components or 4 components that are participating in the transaction, right? What it does is, it's more like everyone executes and then says, I have executed successfully. Once all of the components mentions that it is successful, then only the transaction is set as executed, right? There are 2 ways to do it. One is via choreography and another one is via orchestration. I don't want to get into details, but this is just for your information. So with that, I'll probably hand over the mic to Prakash. He's going to get into the details about cloudlet, statelet, that talks about state management and other information. Yeah, thanks.
Thanks, Prem. And so Prem has already brought to a stage where I can present some additional views. First thing I would like to say is, in the MIC architecture, you saw the architecture, there were at least 11 interfaces, and obviously the new interfaces, and there's a new RESTful API.
Prakash, I think you need to have this too.
Can you hear me now? Okay, sorry for that. Just to get back, Prem really left at a very good point where he brought to the idea of microservices. Microservices is not container, but microservices can be put in containers or can be put in container, could be in VM. So they are not synonymous, that be clear on that. Microservices is simply set of APIs that we can represent a particular function, disaggregated function. So it should be unique function and does only one thing, but does it well. Having said that, MEC architecture, which you saw with all the host management, the system management, host platform management, and platform managing the application, and then underneath the network, all this with MM1, MM9, and then MMP 1, 2, 3, and so on and so forth. All these interfaces, each one have some API. So if I am given a blind check, do implement MEC as microservices. First thing I'll do is, okay, what are the interfaces? What are the APIs? Okay, here are 11. Blindly I can say that I need 11 microservices minimum if the functions are really distinct. Okay. Now there are some interwoven functions you have to isolate, but you can see that a simple implementation requires 11. It is not simple, I'm sorry, but each one of them will lead to many more. So 100 microservices is a very, very normal thing. So it's not out of way. So the complexity increases as you increase more and more decomposition, because you need to recompose them to be able to use any functions on top of it, and the application being the function here. Like in the case of pothole fixing, we said dispatcher is at the edge, and the UE or the tablet or whatever is tied to that bobcat moving around, or ready-made concrete mixer, whatever you call RCC or something like that, with a truck and all. Those two have different functionality. And then that, if I take a UE and if I am supposed to connect to a carrier called AT&T or Verizon, how does it get connected? You need to configure. So basically your authentication comes from the host, which is in the whatever LAN you call IMS or GI LAN or wherever it be. So the HLR, HSS, whatever the entry is there, so you have to configure that, and that configuration gets deployed, because when you go to your retail shop and take a UE, they will say, hey, I will configure it for you. What do? They connect to your local base station and say, hey, this is your home location, here is your configuration. I slap on it, and then that's configured, and that's what you use. So essentially you are tied to a central cloud, not necessarily, which is in the IMS, not at the edge. Then the edge comes, so the dispatch application. So there is something called front haul, back haul. You have a first the access, then the core, and in the access also you are all over the places distributed. So the essential is the concept does exist. Edge didn't happen overnight. It is there, but the only thing is, should we serve from the centralized location, or should we serve from local? And so mid-haul you can call it, but I don't want to complicate more terminology. It's somewhere in the base station. Okay, so you have radio remote radio head, RU and BUs, what you call, or correspondingly in 5G, whatever you call CU, DU and CUs, distributed unit and the central unit. So whatever the units are, essentially it's a distribution of nodes for serving an application. So in that sense, if I build the whole thing, this is like trying to do overkill. That's why if you ask anybody, it sucks, because it's so complex, you can't. So what the MEC has done is, they have simplified by saying, okay, if your mind cannot handle this complexity, think of it as a VNF. So you have a VNF for the MEC platform, you have a VNF for MEC host, you have got a VM for application, or a VNF, or even a container. So simplifying it, the complexity has to be hidden, otherwise it's overkill, and that's one of the problems MEC is facing. It's not that everything is perfect in life. You do have complexities, so we have to abstract. Same way we need to abstract the application. The realization of MEC has been difficult for one of the reasons is that application people think that I run the show, value is here, and so I don't need network. I will put it on some cloud and it will automatically do everything. Doesn't happen that way. To larger extent, to certain extent for smaller application, fine, but when you have to integrate over the entire global network, which is network of networks like internet, and as well as the carrier network, it gets into complexity of security, availability and so many FCAPs, what you call. So essentially this is where the limitation is. So the way to say that, hey, I don't need MEC, why do I need MEC? My application is stateless, I don't care. Well, possible, you can disconnect, you can connect, you can have nomadic, you can have you can have mobility, you can have everything, but it doesn't matter to you because you are stateless. But once you say you need state management, then you get stuck. And network providers, unless they have a stickiness, they are not going to do your work because they need something to provide the revenue value add for them. So essentially this is a battle drawn between the vendors, the carriers, the cloud providers, and the win-win situation will come only when both have something common whereby they can build their own value add services. So this is the crux of this. So I'll move forward, get back to, so this already what you call Prem has explained you, but still I'll just put it this way. The MEC, before MEC was MEC, Professor Satya from CMU started his Cloudlet, and Cloudlet is well known to everybody. There are many open edge computing, and then there are live edge lab and all. I highly recommend, if you need to understand, Cloudlet is a VM at the edge, put it that way. So if you get a VM, you can do anything, and you install a OpenStack as your control instance or a Vim instance which controls the VM. Now, because that is partitioned in the MEC architecture all over places, it looks simple, but then for the state management, they run into issues. They maintain the state on the client side, which is at the device side, and therefore it's able to get over without, for developers, this is good, Cloudlet. But once you develop, when you want to host it and you want to ensure that it is available worldwide in the service provider network, then the migration is a big pain. And that's where the couple of years it has been stagnated. To overcome that, now we have the that is, so if you look at mobile edge platform is the one which supports the services for DNS, for traffic control. So these are some of the things, throughput, all this latency, all this can be managed through the platform services in conjunction with the central cloud, which in this case happen to be HSS and this IMS kind of thing. So application, this is a three-way: edge, central, device. Now how you coordinate between them, I will run through quick one example which shows you how do you manage persistent volume. For state management, because from all this what I have understood after some thought process, and of course I have been working with Prem for quite some time now, trying to figure out where should we, can I go and build 12 microservices and then say, oh, those 12 again spawns another 100, 120 I will do. It's impractical for an individual to embark on it. So what is the main pain point that is hurting this? State management. Application state management is the key. Of course you say, oh, I can do distributed cache, I can do this, but essentially there has to be an API to manage it universally all across platform, whether it's a own app, as Intel helped us in build that, and then we have OPNFV, they have their own way, and the OpenStack has its own way. So everybody has their own way in open, and every vendor has their own way in their private. So where do we go? So essentially what we figured out for state management is, if you are able to instantiate a application instance per user, per application. Having said that, it needs to manage its states on the server side of it, and the server being in this case host. So what we do is we ensure that by attaching instead of ephemeral, as he said, you lose, if you disconnect you lose, no way of recovery. Instead of that, put a VM or put a container. It could be a container or it could be host. So from the looking at it, you can see that admin creates a persistent volume and creates a pool of it and say, hey, this is available to any application. Application goes and picks up, hey, I want to request a persistent volume to be attached to my instance, which is here. Attach it, and all the metadata associated with it for that application. Maybe we can do a unique one specific to application, or you can do it generic if you have the application management capability in the platform. Either way, you can get that, and metadata could be application based, so we can attach and detach. So the only thing in this is I have just drawn a little bit more extension beyond that. Not only you create a VM or attach a volume to it, or you already have a host and you just attach a container with the whatever pod to the pod, and then you use it, and then once you have moved, if the application has to be moved based on the requirement from one edge to another edge, the attached gets detached, next another instance pops up there, or request is ordered through the orchestrator to make that happen, and you attach that state, and then state preserves. So state is preserved. The only thing is you have to instantiate. So computes, as long as computes can handle that, you can manage the application migration in a smooth way without getting into all the details of networking, because that has to be the key. Because once you do at MAC level, then you are in, oh, MAC address changes, how do I do? IP changes, how do I do? So to avoid all that, as long as you know what state is and you can replace that state and able to overcome that, it's a simpler thing. So that's all I have in this, just to give you, this is all I am collaborating. Again, of course, there are, you can describe about the various classes. All of this is available, nothing is new. It's only application of what is existing in Kubernetes, and how do we write the API and system level, admin level API to create pools and to allow attachments to be made and detachments to be made. And then finally, it can be applied to Kubernetes as well as to any of the VMs. And the final one is the user having those objects to use it based on the capacity need and how they list it, how they discover. So there are many processes involved. I wouldn't go into detail at this time. At this time, I would like to just show you the references. There is enough references here, starting from bottom to top. Bottom is being the microservices which Prem has provided to you, and you have got ONAP, OpenFE, and then OpenStack, all COLA for image creation, because image creation, ID management, these are important, LDAP, access. So there are various things which are important for these to be happening. So before I close, I would like to just point out, thanks to Intel for getting us here. I have one announcement to make which is important. We have a edge compute sponsored by Intel, and this is happening at Santa Clara University on May 30. It's the site is IEEE-NFIC. NFIC stands for New Computing, NFIC stands for Next Generation, actually what we are doing in computing, okay? So what you do is IEEE-NFIC.org, Next Frontier in Computing, it stands for. So NFIC and IEEE, this you remember, IEEE-NFIC.org, HTTPS you do, you will get a big picture of, it's only $0 to $70 depending on how you are, and it's a full day 7 with Anita Rao from Intel being the keynote speaker. And then I have, they are talking about how silicon is transforming the networking, and that's a key. And so this is Intel, so you know it. You have, and also we have Google, and there are people from all over, including Stanford, Professor Lam. And so go over it, and if you can, join us. And the other one I have is for OpenFE, ONAP. We have a meeting arranged at Vancouver Summit on Thursday, 24th May between 12:30 and 12:40 and 1:15 or 1:20. It's 45 minutes approximately for the edge computing, so that all these people come and discuss what they bring to table, how we can avoid overlaps, and which functions who can do. That's the idea. So if we can get that, that will be good for the industry, and we hope all of you will be able to convey to your people that we need to collaborate and cooperate to get this up. Okay? Thanks a lot. I think I have run my time. I am thankful to all the hosts here. Sure. Thank you. Please go ahead, line up and go ahead and ask questions.
My only quick question was, what was the location again?
Santa Clara University, and this is hardly 15-20 minutes from here, if you drive. Okay.
It's a long distance for me. I'm from Chicago.
Okay. Yeah, but this is May 30. It's on a Wednesday evening. Wednesday 3 p.m. to 10 p.m. It's a 7 hours, almost with speakers, 10 speakers almost, and one panel with 4 people and 3.
What is the date?
May 30. Just put IEEE-NFIC.org and put a secured one HTTPS and you will get it.
So we can talk offline. You can send us an email and
Yeah.
we'll make sure.
Yeah. Circulate it. Yeah. Yeah. Intel is the platinum sponsor for it. Okay. Any other questions on the subject matter here? What we spoke, microservices or architecture or anything? I hope you will digest it, and I think I should end here. We have next speaker here, and thank you very much for all your patience, and look forward to working with you in the future.
Presenting the correct screen.
All right, good evening. Relax, I'm going to be short. My name is Orla Mooney, and I'm here to speak to you this evening about the network edge ecosystem. And I'll explain exactly what that is in a moment. Now, I know some of you are probably going, oh, for God's sake, it is almost 8 o'clock. I am tired. This isn't even technical. Why do I have to stay here? No reason. You can leave if you like. One minor reason you might consider staying is if you like making money. I kind of do. So if that's interesting to you, you might want to hang around. Anybody here either work for a startup or work for a small company or have dreams of working for a startup and making it big? Yeah, well, from what I've heard, if you live in the Bay Area and you ever have dreams of owning a house, you have to have that dream, because otherwise it's probably never going to happen. So the advantage of this program is that it can help make those dreams come true. Now, you have to do a minor few details first, like have the perfect startup and have the perfect company buy it. But what this does provide you with is something that is necessary, and that's you need 2 things. 1, people have got to know you exist in order to find out about you and want to buy you. 2, you've got to provide value. We can't help you with the second, we can help you with the first. So this is our very exciting legal disclaimer slide. What this should say and doesn't is that if the excitement of this presentation completely overwhelms you and you pass out and we have to call an ambulance, Intel will not pay your medical bills. Okay, so like I said, I'm going to keep it short. They scheduled me for 30 minutes, They only told me it was 20 minutes. I think that's because I work in marketing, and they probably figured somebody in marketing wouldn't keep to 30 minutes. So if they told me 20, there was a chance I'd shut up before 30. But I actually kept it to about 15 in case there was any questions, so I should be able to make up a little bit of time for you. So I've just got 6 content slides. I'm going to go through what the definition of the edge is with respect to this program. It's not a technical definition, as you're going to see very shortly. What are the various players we're seeing in the ecosystem for the edge, and what kind of needs are they bringing to us, and how we think we might be able to address those needs by the formation of this program. And then I'm going to be reaching out to you. We want you to join us, and I'll tell you how you can do that towards the end. All right. You've probably seen 1,001 definitions of the edge at this point. So you can see this one's pretty broad. It's going all the way from the core right through to the access point. And you might kind of go, that's ridiculous. There's no way that, I mean, for me, really, the edge, it's really going to be the next generation central office. It's not going to be all these other areas. Yeah, you could absolutely be right. And you could be going, no way. It's got to be right at the base station. I mean, VR and gaming, they're never going to work if you don't have that latency really right up close to the customer. Yeah, you could be right too. We don't know what the perfect definition of the edge is going to be yet. And so we believe there's actually going to be a number of areas where it can be deployed. Regional central offices out at the base station. So from the perspective of this ecosystem, I don't care. From our perspective, it'll go all the way from the core through to the access point. So if you provide any piece of the solution, anywhere in that, or you consume any part of that solution, then I'm interested in talking to you. Okay. So in terms of who are we bringing into this ecosystem? Any of you familiar with Intel Network Builders today? Guys, you have got to get on this. Intel Network Builders is an ecosystem that we have that's got pretty much all the comm service providers and people who supply the infrastructure that they depend on. So like the ISVs, the OSVs, the OEMs, ODMs, all that kind of stuff. But what it's also got is it's got a ton of training, it's got a ton of resources available, and if you've got small companies there, you've got a ton of benefits that you can grab onto. The fact you're here today and you're interested in all of these networking talks, I can't believe there aren't more of you involved in that. I highly recommend you get involved. So we think that the players who are involved in that today, comm service providers, OEMs, TEMs, NEMs, etc., they're going to be a very critical part of the edge ecosystem as well. But we see it as being wider than that, because we believe that the application developers, the enterprises, and the cloud service providers are also going to be critical for this. So let's take a couple of examples of what the needs are in each case, because it's not universal. The comm service providers own the infrastructure today. But the danger for them is ending up as a dumb pipe. So that last mile, they just end up as a dumb pipe delivery service, but they're determined not to let that happen. So you'll see a lot of, if anybody subscribes to Telecom TV, you see a lot of partnerships forming right now between the comm service providers and various other TEMs, and you see them with the cloud service providers. They're forming partnerships, and they're creating a lot of innovation because they want to come up with these services that they're going to be able to monetize at the edge. They own that last mile, they want to make the most of it. TEMs, OEMs, etc., they've been a really core part of our Intel Network Builders program, I think pretty much since it's founded. They're coming to Intel now and they're saying, with regards to the edge, do you have a reference architecture for us? Do you have a best known configuration? Because we want to make sure that our next generation edge platform, it's going to meet the needs of the target industries that we're going after. So they're looking for help and guidance to us from us for that. Speaking of the target industries, they're also looking to be match made. They want to know who are the ISVs who are in the target industries that I'm going after. Because there's so many different enterprise verticals, they want to make sure that they're partnering up with the right people in order to provide the right kind of solutions. The application developers then, and that's kind of one of the main reasons I'm here tonight. The perception, and don't shoot the messenger, but the perception is that the application developers have kind of a two-tiered view of the architecture. Kind of views their application as either residing in the cloud or residing in the device. They don't really see any need for it to go anywhere else in the network. From our perspective, we believe that the future is going to be an n-tiered architecture. And so what we'd like to see is for those applications to be able to onboard wherever is necessary depending on the application. But we want to provide help to do that. Actually, we missed my bio completely, which is kind of irrelevant, but if you had it, you would know that I was actually a hardware engineer, not software. So I have no idea what you need. I don't know what it is that we can bring to you in this ecosystem from an application developer perspective that will make sure you can onboard your applications as easily as possible to the edge. From a cloud service provider's perspective then, they're already kind of at the edge. I mean, we already have AWS with their Greengrass. Microsoft Azure has also created an edge version of the public cloud Azure, so they're already there. What we see with the cloud service providers coming to the edge is if we enable them on the edge, you're automatically enabling a whole host of solutions, applications, and developers who have already been developing on that platform. So we consider that really advantageous. That nirvana situation would be develop once, deploy anywhere. So it doesn't matter whether you deploy it on public cloud, on the telco edge, on the on-prem edge, be all the same. Then from the enterprise then. So from an edge perspective, the edge is only going to succeed if it's solving a problem somebody truly cares about. Now, if you've got a problem you truly care about, you're willing to put your hand in your pocket and actually pay for the resolution of that problem. And to date, with the POCs that have been done on the edge, the ones I'd consider successful. So when I say successful, it's more than just one set of machines in a lab. It's actually made it all the way to a field deployment. They have been driven by the enterprises. So what we want to be able to do in this ecosystem is put together full solutions for them. So they've got the hardware, they've got the software, they've got the applications they need on it. But the problem is the enterprises are so wide and varied. You've got the financial services, you've got medical, you've got retail, you've got industrial, you've got automotive, transportation. Where are you going to start? How do you make those decisions? Okay, so what is the network edge ecosystem? And how is it going to address any of those problems? So it's a technical enabling co-marketing engagement, which is focused on edge solutions and offerings. So as I mentioned, there are strategic partnerships already forming in the industry. So as I mentioned, Nokia have formed one with AWS, and every time you kind of look at any of the telecom publications, you'll see new partnerships forming. But there's more to be done, because the TEMs are coming to us and they're asking for guidance on the ISVs. We have others coming to us going, we want to do a POC, but we need an application that does X. So all of these partnerships need to be formed. We want to use our scaling tools so that we can provide guidance on what reference architecture can you use. What will actually be what will be suitable to deploy on the edge. And so we have solution testing and optimization facilities within the ecosystem. We have our Intel Select solutions, which I don't know, Sujatha, whether or not you've had a talk on Intel Select at some point. I figured you probably had. And we've got solution collateral development can help with all of that. Then for our scale programs, as I mentioned on the enterprises, there are so many of them. Where do you start? So our 5G team has decided where to start. And they've chosen 4 verticals that they're going to focus their efforts on to begin with. They're industrial, automotive/transportation, retail, and smart cities. So the idea is that we'll engage, those areas have already had some POCs and they have some use cases and they're gaining a little bit of traction. So the idea is to focus in on those areas, basically find out what we can learn from each one. And the first one's going to be a disaster. All we'll probably do is make mistakes left, right, and center. But they're the mistakes we're not going to make the next time we try scale to a different vertical. And so each time we would expect to be faster and more efficient in being able to scale through the verticals. And once we have gone through those 4, the world is our oyster. We can then move on to the financial services, medical. We'll have a lot more flexibility on being able to supply targeted applications where they're actually needed and how they're actually needed. So how do you actually join? Oh, just on the matchmaking opportunities with end users. As I said, this isn't going to be very helpful if nobody actually wants to buy it at the end. And the enterprises are the ones that we anticipate are going to be writing the checks. So what we want to do is a layered approach. So in terms of recruiting for the ecosystem, we started with our Intel Network Builders, which I was kind of shocked how little you knew about that one. IntelNetworkBuilders.com, by the way, you need to check that out. And that has a whole bunch of, we have I think about 290 members I think in that. And what we did is we went through it quite selectively on those we knew had edge solutions, and we reached out to the field going, okay, who on the accounts you deal with you know are actively involved in the edge. Now, the edge is a real buzzword right now. Everybody's kind of, oh yeah, I'm interested in the edge. What do you do on it? Yeah, I kind of check what other people are doing. That's not what we're looking for right now. We want to have people who either have market-ready edge infrastructure solution, or they can demonstrate they have traction towards an end solution. So once we have that in place, the idea is that we want to bring in the consumers of those solutions. So we want to have the layer of creation first, and the layer of consumption above that. So this is, I kind of thought I'd be skipping over this one really quickly because I thought you'd all be familiar with Intel Network Builders and you'd be familiar with everything that this gets offered. Now, I know that some of you are going to look at this going, this is marketing rubbish. I don't need to be worried about this. And yeah, that's fair enough. But remember what I said about the beginning, if people don't know about you and don't know what you're offering, they're not going to care about you and they're not going to be interested in investing in you. So what this can provide is we offer a number of these benefits already with Intel Network Builders. Now the difference is that Intel Network Builders is, because it's become so big, it's going to almost like, it's developing something called a winner circle. It's a bit like a tiered model. So these kind of benefits are not going to be available to every single member. It's going to depend on which Intel Select solutions you're promoting, etc. It's going to be kind of tied to a points type system. The edge is going to be a little bit different on that because we're focused in very much on wanting to gain traction in this area. So even if you're a really small player, but you've got a really compelling story around the edge, and that's something we can promote and something that we can highlight to other partners. It doesn't matter how small you are, it doesn't matter what else you have or haven't done with Intel, that's attractive to us. So the kind of things that are on offer, you've got keynote speakerships. We did the event we actually launched the ecosystem yesterday at the Layer 123 Zero Touch, the NFV and Zero Touch event in the DoubleTree in San Jose. We did like 7 chip chats with various partners who had joined the ecosystem program. We do publication developments. Each one of those customers has got a microsite on our Intel Network Builder site. They have a separate tab highlighting all of their edge solutions. Because we want it to be easy for people to find what edge solutions are already out there and how they can avail of them. So you'll be delighted to hear, given that it's 8 o'clock at night, that this is my last slide. So where are we now? As I said, we launched yesterday, where we are actively recruiting across all 5 of those areas that I mentioned. Putting less of a focus on enterprises right now because we do want to have the solutions in place before we kind of invite in the consumers, but some are already involved. We're already speaking to a number of the car manufacturers and that because we're already dealing with them through our autonomous driving division. So we're kind of making them aware that this is coming. But I'm very, very interested in application developers, and I'm really interested in knowing, what do you need? Do you need technical help? Do you need marketing help? If you need technical help, what kind of technical help? Is workshop kind of thing helpful? Is it individual engineer to engineer relationships you need? I'm not saying we can accommodate everything, but if I don't know the needs, we cannot address them. So that's something that I'd really, really like this group to help us with. And then I want you to go to the website, which is networkbuilders.intel.com/network edge ecosystem. And there you'll be able to see the kind of stuff. It's only just started. We just kicked off yesterday. But you'll be able to see what the vision is. And hopefully we'll be able to bring that vision to fruition, but we need your help to do so. So if you have any questions, I'd be glad to take them. Otherwise you can get out of here. But all this, I think you have what, ideas roulette yet next and something else? Yeah, so.
Just a quick question on
Sure.
the slides. You had the word optimization on one of them. What does that mean in that context?
Sorry, at which optimization?
I just said that optimization as a word on one of the slides. I just want to understand.
So funny enough, we are Intel. So part of what we will want is to make sure that everything runs extremely smoothly on IA. If something's not running well on IA, that's something we're going to want to address, and we would have engineers to help with that. Anything else? All right. So I've managed to get us back on time. In fact, I think I might even have us slightly ahead of time, so I'll hand over to Sujatha to finish up the last couple of slots.
Thank you, Laura. So that was an energizing talk. Thank you.
Oh, thank you very much. Thank you.
And here's something for training.
Do you need this?
While we are doing this, the surveys are open, and I apologize that the link that I showed on the slide was outdated, but you have those little notes or slips. The link is on there. So last chance to do the surveys, we have the grand prize. Can you bring up the
Yes.
slide?
So the survey is the zip gift card.
So I'm sorry, there's only one pack, but there are two gifts
Yeah.
in
We're
there.
gonna have it back.
Thank you.
So this is a $50 Amazon card for the survey, for the winner of the survey drawing. And then for the winner of the Eventbrite drawing, we have a Google Home Mini. So let's do the, you want to do the Eventbrite registration first?
Yeah, why don't you do that?
What about the
And,
idea reel?
yeah, so before we do the idea relay and all, those who were there in the afternoon probably remember me mentioning about the early innovation project. And so one of the innovators is here, Frederick. So I'll just bring his project up and he can talk to us.
Okay, hello. So my name is Frederick House, and so the idea that I proposed is quite simple. So the idea is to bring artificial intelligence to the data plane of networking. So if you look at various SDNs, right now there's no. You have a set of roles and actions and so on, and there is a little bit of deep packet inspection you do in some of the SDNs. But they're pretty much very rule-based and some simple heuristics in some cases. And so part of the idea is, like, what can we do if we were to bring AI? Like, what kind of DOS mitigation or quality of service or so on that where we can inspect, try to work out what the traffic looks like of a live system, and then try to make decisions based off of that. So there's multiple phases that I'm looking at. First one is to generate a set of data sets that can be used that basically capture live traffic and post them for people to start working with. The second one is building a set of tools to normalize, to annotate the traffic and put them into a format that, like, if you do a TCP dump, then you should be able to capture that and then send it off in order to get it properly trained. And then the third part would be to build a set of initial models and so on, and just do some basic AI to start with. And the idea is to try to lower the cost of entry for people who want to build AI solutions that work within the data plane. In the long run, so as you say, some stretch goals would be to start to build out the infrastructure so you can consume those models and start to do things like hardware offload or integrate them into other SDNs like the Prime Bank, VPP, or ODNL, or so on, and essentially provide a way to provide that decision making and with AI. So in a nutshell, that's what I'm looking at.
Yeah, that's his point. Yeah. I don't know if he's filled up the profile, but
Yeah, I filled it out, and like always, like I plan to make the stuff that I'm working on here open source. So feel free to jump in, and if anyone wants to help, by all means, feel free to join in.
oh yeah, that's your LinkedIn profile. I don't see much details on DevMesh. You can maybe populate that on DevMesh.
I populated the project, but I'll populate my.
Yeah, perfect. Yeah, perfect. Yeah. Thank you. Thank you for doing that. Actually, LinkedIn reminded me. There were some people who mentioned about DPDK. How many know him? Okay. One person. So, oh yeah, okay, yeah, I guess. So I don't know if you guys know that he passed away recently. He is basically the father of DPDK, or employee number one for DPDK. He had a battle with cancer, and so just a moment of silence for him. He was a big contributor to the open source community. Okay. With that, we'll move on. Yeah.
Go backwards, Mark.
Okay. Last call. Did any other teams come up with any thoughts on the idea relay cards? Anyone wants to share before we do the drawings for the prizes? Anyone? Last call. Okay, I guess. Yeah, let's give the idea relay, and then we'll do the rest.